trig ratios, we had sine. And we use that theta to show the angle. So if I do sine of theta, what will sine equal to? What two sides did we work with? Opposite over hypotenuse. Good. So you can flip back to yesterday's work for this. Otherwise, Mr. Kwan did a really amazing job drawing it out on this whiteboard here.
And we still find it hard to kind of remember. Ms. Noah's going to teach you an easy way to remember that.
All right, then we have cosine. Cosine of theta is what over what? Adjacent over hypotenuse. And how, Milton? And what was the name of our last one? Tangent. Good. So tangent of theta. And this is the one that's different. It doesn't have that hypotenuse in there. Tangent is what over what? Good. Opposite over adjacent. All right, so there's this mnemonic device. Mnemonic? I don't know. There's this device that we use to memorize this to just help us, and you'll hear other teachers say this. It's called SOHCAHTOA. SOHCAHTOA. So as we look at SOHCAHTOA, so stands for sine, and it goes sine is S. And then we spell so, S-O-H. What would the O and H stand for? Good. Opposite and hypotenuse. So you have so, and then it goes ka, C-A-H. So ka means cosine, and cosine is adjacent over hypotenuse. And then we have TOA, T-O-A. T stands for tangent. O stands for opposite, and A stands for adjacent. So it kind of tells you if you're given two of these things, and we're going to come back to this the whole time. So if you want to highlight that, that's a really important part. It's going to be part of your practice today, just to remember that so, ka, and then toa. Okay, if as you're highlighting, it helps you to do S, and then O over H. Cosine is A over H, and tangent is O over A. So if you want to highlight that to kind of show where we get that so, ka, toa. We're going to be talking about that tomorrow as well when we do angles of elevation and depression. Oh, that one. Perfect. All right, and that's something that as you go throughout your college career or as your high school career, you'll hear other teachers say SOHCAHTOA. All right, if you Google it, I will give you a warning. Little heads up. Some teachers have created this weird background story to this word SOHCAHTOA, or this phrase, and it has turned weird. So don't watch YouTube videos about it. Just Google it. It's weird. All right. We're going to go ahead and find missing side lengths today to start with. So I'm going to do this little asterisk, missing side lengths. And then you're going to get one glue in to start with. And it should be the one with the 35 degrees. Yep, and then make sure that you have that flipped the right way, other way. All right, so with your glue in, we're going to do missing side lengths first, and then this glue in goes right underneath. Make sure the X and the 13 are at the top. And as we work, I'm going to use one colored pencil today, just to differentiate my thinking from my actual work. What we think, I'm going to put it in our colored pencil, and our work I'll actually write in our normal pencil. Alright, so go ahead and get that glued in. Find one colored pencil. Get started on that next problem in about 30 seconds. Alright, so on this one we're finding a missing side. We're finding our x, our value. So first thing we're going to do as we take a look at this triangle is we're going to decide what the sides are. So there's always one side we can always identify right away off the bat. Is that going to be the opposite, adjacent, or the hypotenuse? Hypotenuse is the first one we can always find. It's across from the 90. So if I put my finger on the 90-degree angle, I want the side that doesn't touch that. So is that the 16, the blank side, or the x? Good, the x is my hypotenuse. So that's why I'm going to put this in color pencil, because this is what we're thinking as we go. So this is my hypotenuse. Okay, my angle, my reference angle here is this 35 degrees. So if I'm looking at this 35 degrees, I want to know opposite and adjacent according to that 35. I always start with opposite. That's the way I work. My brain works better that way. So what's opposite of the 35? The blank side or the 16? 16. If you're not sure, put your finger on that 35 and say which side doesn't touch it. The one that's not touching it at all is that 16. So that's my opposite. Which means my last side is adjacent. So as I work through this, the two sides that I'm given, one side is the hypotenuse, the h, and what's 16 represent? Opposite, the O. So as I look at hypotenuse and opposite, I can think through my SOHCAHTOA. Am I going to be using sine, cosine, or tangent based on those two sides that are marked? Which one uses opposite and hypotenuse? Sine, cosine, or tangent? Yeah, so this tells us we're going to use sine. So I'm going to write sine. And remember when we write sine, we just do S-I-N. We just use the three letters. And then I need my angle to go after my sine. So what is the angle measurement? 35 degrees equals and then I want opposite over hypotenuse. I'm going to just write that there. Opposite over hypotenuse. So what is my opposite? 16 over my hypotenuse, x. And our goal is to find that x. We do that just like we did in Chapter 7. Our goal is to get x by itself. Right now, x is in the denominator. Do we like it to be in the denominator? Nope. So we're going to flip it. We're going to flip this over and say x over 16. But if I flip that side, what do I have to do to the other side? Flip it. So I have to think of this as a fraction. And if it's hard to think of it as a fraction, I'm going to imagine it's always over what number? 1. Good. So as I flip it, it'll be 1 over sine of 35. And then our goal is just to get x by itself. So how would I undo a dividing by 16? What's that inverse? Multiply by 16. So I'm going to do times 16 if we do it to one side. Do it to the other side. So I get x equals, and now this is the part that I'm going to put into my calculator. Okay, if you need to write a little note to yourself, just to remind yourself when you look back at your notes that this is where we use Desmos, or use your calculator. Now, if you're going to use a calculator that's not Desmos, you have to be really careful. Our Desmos calculator is always in degrees, which is great. There's another way to measure angles, and that's called radians. If you have it in radians, our numbers are going to be different. So you always want to make sure it's in degrees. And in Desmos, to know that, it says it right here at the top, DEG, degrees. That's what we want. Okay, Desmos is always in that spot to start with. All right, so as I do this, I'm going to do 1 divided by the sine of 35. So sine, and then 35. And then I want times 16. Do I want the times 16 just on the bottom or off to the side? Good, off to the side. So times 16. Okay, and we're going to round to the nearest tenth today. So do I want to keep this at 27.8 or round to 27.9? 0.9. Good, 0.9. Beautiful. So on your Desmos calculator, the sine, cosine, and tangent are all on this bottom row right here. They should be on that very first part. If you're using your phone calculator, you have to be really careful. First off, you have to turn off your lock rotation if you have an iPhone. You have to have your phone unlocked. Then you have to move your calculator sideways. And then you have to make sure that you're in radians or degrees. And if you're not sure, here's it says RAD down here. We want that to say degrees. Nope, we want it to say rad, apparently. I don't know. If it says radians up there, that's bad. Degrees. And then your sine, cosine, and tangent are right here in the middle. Okay, you have to type in the number first, then hit that. I wouldn't recommend it. At that point, it's just way more work to use your phone calculator rather than just Desmos.
Same thing when you do square root for the last chapter. So really it's easier to use Desmos than to use your phone calculator. And if you want to still use your phone, you can always download the Desmos calculator like Miss Mall has it on her phone.
Or go to the website too, on your phone. All right, here we go with the next one. So first thing we're going to do is we're going to identify our different spots. Which sides are we given? So I always start with my hypotenuse. Is my hypotenuse the x, the 13, or the blank side? Good, the blank side is my hypotenuse this time. I'm looking at 30 degrees as my angle. So if 30 degrees is the angle, that's my reference angle. It's what I'm going to refer to. Based on 30 degrees, which one's my opposite? 13 or x? Good. X is my opposite, which means 13 is adjacent. So I'm going to take a look and see what sides I'm given there. I have x is my opposite, so that's my O. (13) is my adjacent, my A. So I have O and A for my sides. So I need to decide which function am I going to use with opposite and adjacent. Is it going to be sine, cosine, or tangent? Good, tangent, because tangent is opposite over adjacent. You can either use these letters to help you with just O and A, or if it helps you to actually look at the full ratios, either one is fine. We want the one where we use both of those, so O and A. So we're going to use tangent. So we'll say tangent of, what's our angle?
What's our reference angle?
30. And then for tangent, what do I want on top? Is it opposite over adjacent or adjacent over opposite? Good. Opposite over adjacent. So what is my opposite? X over my adjacent? 13. All right, so as I solve this one, do I need to flip it over like we did on the first one? No, why did we flip this one over? Good, X was on the bottom. Is X on the bottom? Nope. So all we have to do this time is get rid of that dividing by 13. And how would we undo divide by 13? Multiply by 13. Good. If we do it on one side, do it to the other side. So in my calculator, I'm putting that tangent of 30 degrees times 13. So again, tangent's down here at the bottom. I'm going to throw in 30 degrees. And then times 13. I want to make sure that that times 13 is on the outside of the parentheses, not on the inside. And it looks a little silly right now because I have it in in big numbers so we can all see it. But this is what it should look like in your calculator. So then we can see it. So 7.5, or should we round to 7.6? Good. You guys are so good at rounding. It's insane. All right, and the reason why we can do this is the reason we can use this tangent and this sine is that the ratio for 35 degrees is always the same. The tangent of 30 degrees is always the same. All right, we have one more that we're going to do. Don't back up yet. We got missing angles. If you have enough space, you can put this in on this page. It's going to be a little tight. Might be better just to put it on the next one. You're going to get one more glue in. I probably should have just done it on the next page, but too late. You're going to get one more glue in. We're going to glue it in on this side, or right underneath, missing angles. All right, so it'll give you about 30 more seconds to get that glued in. Again, I probably would have done it on the other side, but I didn't, so I'm going to write real small. So I'll try and make sure I zoom in for you. All right, on the next page, not other side. I don't know why I keep saying that. All right, so first off, let's identify. We're still going to start by identifying our sides. So which side is our hypotenuse? Good, the blank one, the one that's not labeled. That's our hypotenuse. It's across from my 90 degrees. The hypotenuse is hype. Miss Morella, you're so funny. I know. Thanks, guys. All right, for opposite and adjacent, we need to know what our reference angle is, and that's this question mark. We don't know the angle amount, but that's where we're looking. So with this 2 and 5, we need to label one of them opposite and one of them adjacent based on that angle. So take a second, think which one's going to be which. Good. 2 is opposite, which means 5 is adjacent. So I'm looking at the parts that I'm given. Okay, and the parts I'm given are the 2 and the 5. So what two sides is that? That's our opposite and our adjacent. So we have an O and an A. So opposite and adjacent. So we're going to use, it's not called tan, it's called tangent. Tangent. Good. So we're going to do tangent because we have O and A. All right, Hamsi, refocus. You can do this last part. All right, so we have tangent of, we don't know our angles. We'll do like a question mark, or we might use theta there. Equals. And then we want opposite over adjacent. Should have done this on the next page. This was a mistake. Regretting everything. All right, what is my opposite? 2 over my adjacent? 5. And now our goal is to figure out that question mark. And we do that by using inverses, similar to what we just did in the beginning. If I have adding, what's the inverse of adding? Subtracting. What's the opposite of multiplying? Dividing. So we need to think, what's the opposite of tangent? Okay? And you don't know the answer to that, so don't say it, because unless you've taken this class before. The opposite of tangent is called tangent inverse, or inverse of tangent. And it's like a tangent with this little exponent of -1. And essentially what that does is it just undoes tangent. Super fancy. Their calculator does that. Back in my mom's day, she had to have a chart, and she had to use the chart. It was a whole thing. She explained it to me many times, and I said, cool, we have calculators. And that's probably what you guys are like too. But if I do it on one side, I have to do it on the other side. So I'm going to do tangent, and then that inverse with that -1. And in your calculator, you'll have parentheses, so we need to say what we're doing that to. What is the fraction? And that's 2 over 5. So that undoes the tangent. We're going to be left with just what over here? Just the question mark. Good. Now, to find tangent inverse on your calculator, it's a little bit more complex on Desmos. And by complex, I mean you have to hit one extra button. Okay, a couple ways to do it. You can either hit tangent, but then when you hit tangent, you can go back and do an exponent of -1. And then that will work. Okay, that's a little silly though. What I would do is I would hit this func button. That stands for functions. And then they have it right here, and it's paired with tangent, this tangent inverse. Okay, either way, you get the same answer. You have to go back to main to get to your numbers, and we're going to put 2 over 5. Okay, and it tells us our question mark will be 21.8. And this is an angle, so what are we measuring it in? Degrees. All angles get degrees. Okay. Really should have done this on the next page. That was my bad. Okay. Stressing me out. 21.8 degrees. All right. Sometimes when you get triangles, they're going to be labeled with their vertices. So let's label this one. Let's label this M. N. Hey? I do. Can you give me 1 second? Okay. And L. What class are you in? Okay. What do you need? Big ones or small ones?
Big ones.
Like big ones? Or like big ones? Big ones? Okay. Can I come bring them to you in a second? Okay. So M, N, and L. Which angle are we trying to find? M. Good. The question mark is M. So a couple people are getting good at this where they don't have to label all 3 sides. You might be able to look at M and decide just what 2 sides you're given. Okay? Some people can jump to that. If I look at M, what is this 49? Is that opposite, hypotenuse, or adjacent? Good. It's across from the 90, so that's my hypotenuse. And what about my 33? Is that going to be my opposite? Is it across from the M? Or is it touching the M? It's adjacent. Adjacent. Good. So here I have adjacent and hypotenuse. Some people, that's not how their brain works. They need to go through all three and label this one as opposite. That's fine. It takes you an extra 10 seconds, not even. All right, so if I have adjacent and a hypotenuse, which function, going back to the top there, or you can take a look over on the board, which function am I going to use with adjacent and hypotenuse? Good. Cosine. Remember, it looks like cos, but cos means cosine. It's like sine. It's together with sine because it has that hypotenuse. Good. So we're going to use cosine. I'm running out of space here. So I'm going to say cosine. Instead of question mark, let's use M. Sometimes we use that vertex, that angle M, rather than using a question mark. You might see that in your practice today. I can't remember exactly. Okay, equals. And then the biggest thing here is making sure I set up my ratio correctly. Is it going to be 49 over 33 or 33 over 49? And that comes back from cosine. Cosine is what over what? It's what over what? Adjacent over hypotenuse. That's that ka. You know, it goes C-A-H. So my adjacent is 33 over my hypotenuse, 49. And then my goal is to solve for cosine. I'm sorry, not solve for cosine. What are we solving for? M. So how would I undo this cosine? What's that other word we use for undo? Starts with an I. Ends in inverse. Cool, inverse. You guys are crushing it. That's okay, that's new to us. So cosine and then that -1. And that stands for that cosine inverse. And that's just a fancy way to say we're going to get rid of that cosine. Okay, let's cosine inverse. And if we do it to one side, do it to the other side. So on this side, I'm going to do cosine inverse. And in my calculator, I'll have to put in that fraction, 33 over 49. Okay, so in my calculator, I'm going to find that cosine inverse. To get to that, we have to hit that function button. Find that cosine inverse there. If you're on your computer, it's nice because you can just use your numbers at this point, but otherwise you have to go back to main. 33 over 49. Oops. And we get 47.6 or 47.7. Good, 47.7. And it's an angle, so we'll label it degrees. All right, and I really almost ran out of space there. That's insane. All right, so for your practice today, what's going to happen is there's going to be some questions. The first question is going to ask you about that mnemonic device, SOHCAHTOA. It's really easy. And then the other questions, as you work through it, the first thing you're going to do is identify the 3 sides that you're given before you do the work. Does that make sense? So it's going to be drag and drops. And the first thing you're going to do on your drag and drop, starting at number 2, is identify your opposite, adjacent, hypotenuse, and then use that to help you decide which trig function to use.